If you are still confused about what is a flight controller and what is an electric speed controller, then this video is made for you. Plainly speaking, a flight controller and an electric speed controller are two of the essential components of an FPV drone. In this video, we will be deep diving into them as I will be explaining the purpose of each of what they do. We will also look into the solder pads one by one, most of it, so you know what they are for and what components they are supposed to connect to. As MEPS King is kind enough to send me their F7 flight controller and their 60 amp, this is the F7 flight controller, and their 60 amp electric speed controller, we will be using them as an example to demo this. Before we begin, take a deep breath, and this is going to be a good 5 to 7 minute packed with a lot of information. Let's go. Let's first look at the flight controller, and flat simple, this is going to be the brain of your FPV drone. All the components like the radio receiver, FPV video system, ESC, or even your beeper will have to be connected to the flight controller in order for them to function. With all the external components connect to the flight controller essentially becomes a hub of data, and the flight controller is going to process these data with the little processor chip on board and transmit these data into commands to start up the motors or make your drone go left and right. The flight controller will also have a pre-built gyro chip on board to manage the balance of the drone in air, which is also a very crucial part of the drone performance. Next, let's look at the 4-in-1 ESC, which the full name would be Electric Speed Controller. The basic function of an ESC will be to acting as a circuit and kind of like a sub-brain between the flight controller and your motors. When you make a stick input, the FC is going to the flight controller. FC, flight controller, will send a signal to the ESC to tell how much current it should be sending to the motors to tell how fast the motors should be spinning. Why is it called 4-in-1 ESC is due to the board basically consolidates 4 individual ESC onto one single board. Simple as that. And why do you need 4 ESC is because you are going to have 4 motors and they will be spinning at a different speed depending on the maneuver you are trying to perform. So this is why you need individual 4 ESC to manage individual motors. And to make it simpler, they just built a 4-in-1 ESC, so everything is one chip, so you don't have to have 4 pieces of components. Next, let's briefly look at the solder pads on both, so you know how they connect to each other. Before I begin, I want you to know there are only 2 types of solder pads. This is a general idea. The first type is to receive power, which you're going to see plus and minus, or it can also display as V or ground as G and D. The second type of solder pad is going to be for data transfer, which is often displayed as TX as transmit or RX as receive. And for certain components like a beeper or GPS, the pads might display differently, but the purpose is going to be the same. So let's go again. There's only 2 types of solder pads, which is going to be one that receives power and one that transfers data. For now, I want you to know every components that you have to solder onto stuff generally will require both types of connection for them to work. You will need power to power the components and data to talk to the flight controller. Bear this in mind so it will be very easy to understand later on. Let's start with the ESC first. The ESC is much simpler. There are 2 main components you need to solder to it. The first one is going to be the power cable, and the second one is going to be your motors. It's motors to the ESC. So let's first look at the power cable. That simple. It's going to be somewhere in the bottom, like separate in the others. There's going to be 2 big pads, and you're going to see there's going to be a plus and minus sign. And the plus will have to be your red cable, and the minus is going to be your black cable. As for the motors, you're going to have to connect your motors to the ESC. And each of the 3 pads is going to be 1 ESC. So 1, 2, 3 is 1 ESC, 1, 2, 3 is 1 ESC. And then let's pick up a motor to see how a motor is constructed. So motors generally is going to have 3 wires, and as long as you solder these 3 wires into the same ESC, it should be totally okay. You can mix and match them, tangle them, whatever you want. As long as it goes to the same ESC, it should work. The problem is you probably will have to adjust later on in beta flight to make the correct direction. But just for clean purpose, I will still suggest you solder it based on the sequence. Additionally, for these three wires, one of them is going to be plus and one of them is going to be minus, and one of them is generally going to be your signal for the ESC to know how fast the motor is spinning to calibrate. All right, so that's about for motors and the power cable. And one last thing we have to do is to connect the ESC to the flight controller. Otherwise, it's not going to work. Flight controller is not going to get power, and the ESC doesn't know what to do because it doesn't have a brain. In the motor stack like this, generally, they are going to provide you with a cable. This is not the exact one, but just for example. So they're going to provide you a cable like this for you to plug in right here, and the other side will go to the flight controller. If you are mix and matching different brand of ESC and different brand of flight controller, do make sure to check that plus goes to plus, minus goes to minus. These are the two most important things, because if you accidentally plug them wrong, you're going to fry them. So since these are the same brand, simply plug it in with the original cable that comes with the ESC and you should be good. Next, let's look at the flight controller, and there are much more items you need to connect it to make the drone work. The basic minimum items are your radio receiver, like your ELS receiver, and an FPV video system. A radio receiver will allow you to control your drone with your radio, and the FPV video system will allow you to see footage in your goggles from your onboard camera. For radio receivers, we will be using the ELRS as example. You will need 4 solder pads in total. So very simple. If you remember what we talked about, you need power and you need data. So power is going to be your ground and your 5 volts, and the data is going to be your T and R. So TX transmit, RX receive. If you wanted to have a detailed guide of how the ELR solder is done, you can check the video right here. It should be an entire walkthrough. All right, let's go to the next stuff. For the FPV video system, the connection for analog and HD is kind of different. Analog generally requires you to connect the camera and the video transmission chip separately to the flight controller. So basically, a connection of the camera receives the signal, goes into the flight controller processes the footage, and then sends out via the transmission chip to your FPV goggles, and that's how you get footage. This particular board is not the perfect one for the analog system because it does not have an in and out pad that you can solder directly. If you wanted to know how it was done, check this video. It's going to be much more detailed than this one. Next, let's move to the digital video system. For digital, we are going to use DJI as example. To connect a digital video system, it's generally going to be simpler compared to analog. As the current flight controllers on the market, if you buy the HD version, they will generally come with the plug directly equipped it on your flight controller. So it's going to be a simple plug and play. And since the HD video unit are generally going to look like this, that the camera goes into the transmitter and there's no need to connect the camera separately, so it's going to be very simple. Just plug it in and it's going to work directly. But if your particular flight controller does not have any plugs, the connection can still be done by soldering to a 9 volt or above battery pad, a ground, TX, and an RX pad. So 4 connections, a battery pad, ground pad, TX, and RX. Just remember your battery pad is going to be required to be 9 volts or above. Besides the essential parts, there are the 2 commonly additional components that we can install to a flight controller. The first one is going to be a beeper. Basically, it's a thing that basically when you flip a switch or if you lost your battery power, it's going to beep so you can go find it. And a GPS module. So for beeper, it's very simple. You're generally going to find whatever pad that has a B to it. That section is going to be where you're going to solder your beeper. Same power, very easy. The red one goes to the 5 volts, the black one goes to the ground, and the additional one that's coming out as a beeper cable, you're going to just find the one that has a B word and solder to it. Occasionally, you might see a section that has the ground marked as B minus. That's when you just put the black one instead of the ground, put it to the B minus. Simple. As for the GPS, if you're using beta flight, there are only 4 connections required. Same, you're going to need power. So power, 5 volts, second one ground. You're going to need a transmit and you're going to need a receiving. So these are the 4 paths essential if you're using Betaflight. And if you're using iNav or something else, then you can solder the SCO and SDA. I don't use iNav, so I don't know what these actually does, but Betaflight does not support them at the moment, so no need to solder these two. So all the things you're going to need is going to be 5 volts, ground, T, and R. All right, very simple. All right, so I think this basically wraps us up this video today. And I know there are many types of different ESC and FC on the market, but as long as you remember, most of the stuff requires power and data to work. You should have no problem, and it's going to be a piece of cake for you. Anyway, I hope this is helpful, and if you have additional questions, please help me leave it at the comment section, and I will do my best to respond to you. And if you can, please help me subscribe. It means a lot to me, and I will see you in the next tutorial. Bye for now.